Hi there. I have here a table which stores sales information. Unfortunately, back in the midst of time, someone decided to store the shipment dates as numbers. Every Monday, I run a query to get stats for the past week. Normally, this runs nice and quick. But at the start of each year, something strange happens. The query takes a really long time to execute. The next week, performance is back to normal. The queries process the same amounts of data each time. So why is it so much slower those first few days of January? Let's step back. In both cases, the time period is 7 days. And when the start and end dates fall in the same month, that's how many values there are between these dates as numbers. But when the dates cross a year boundary, the difference between the numbers is in the thousands. This difference is the root of the problem. But Chris, I hear you say, I thought you said the optimizer was smart. Surely it can figure out that these queries return the same number of rows. Well, think about it this way. When I've got both my eyes open, I can juggle these balls easily. But if I cover one up, I lose my depth perception. The task becomes a lot harder and I'm much more likely to drop the ball. When you store dates as numbers, you're partially blinding the optimizer. It struggles to see the real information, so it's much more likely to make a mistake. When it runs quickly, the query uses an index. The number of rows the optimizer estimates is in the same order of magnitude to how many rows it actually processed. But when the query crosses a year end, it switches to a full table scan. It's expecting far more rows than it actually returns. This is the core issue. For Oracle to choose the correct plan, the estimated rows should be in the same ballpark as the actual number of rows it processes. So how can you improve the estimates? It'd be nice if you could tell Oracle exactly how many rows there are for each value for shipment date, and you can using a histogram. This stores how many rows there are for each value in what Oracle calls buckets. For values that don't exist, there is no entry. To estimate how many rows there are between two values, Oracle can sum the row counts for the matching buckets in the histogram to get the row count. But there's a catch. There's a limit to how many different values Oracle can store exact row counts for. This is 254. That's less than a year. Unless you have an aggressive archiving strategy, for most cases, this is too few values to state exactly how many rows there are for each day. So, does this make histograms useless? No. If you have more than 254 values, each bucket covers a range of values. So, while the optimizer doesn't know that some values have no rows stored against them, it does know that the values we're looking for fall within a given range. This gives an upper bound for how many rows the query returns. Using histograms, the optimizer may still get its estimates wrong, but it's less likely to be so catastrophically wrong. Adding one may be enough to fix your performance issues. But what if it doesn't work? What else could you do? It's time to revisit function-based indexes. Instead of a plain index, create one that converts the numbers to dates. With this in place, Oracle's able to have much better estimates. To use the function-based index, you need to update the query to match the expression in the index. Do so, and you'll get nice, consistent performance again. Let's recap. We saw in the previous video how storing dates as strings can lead to unexpected errors. Here we see another problem with storing dates in the wrong data type: inconsistent performance. While you can work around this using function-based indexes or histograms, the proper solution remains the same. Store a date in a date. Thanks for watching. If you enjoyed this, then please subscribe to my YouTube channel for more SQL magic.